Does this work? Hey, it's working. I can hear myself. A little bit of history about myself. I am a native Texan, Panhandle, born in Borger. Didn't stay there very long. Was raised in the central part of Oklahoma, 40 miles north, well, 30 miles northwest of Oklahoma City now, because Oklahoma City keeps growing. Raised on a wheat cattle farm with my grandpas and my uncles, so at the age of 12 I started driving tractor and figured out there's probably better ways to do it, so done a little bit of everything in my career. So been out at Goodwell for 14 years now. I'm the area research and extension specialist out there, and then I'm also the state sorghum specialist for Oklahoma. So anybody know what that is? Yeah, that's what we're here talking about all today. That's a water molecule. I just thought I'd kind of throw that up there for everybody to look at it. Well, I always remember a water molecule. It's an upside down Mickey Mouse. So that's what we're talking about, conserving, using, and doing all that stuff with. So why do we worry about tillage? Because it affects what I call, quote unquote, effective water. Effective water is water that the plant actually utilizes. Gets to the roots where the plant can use it. It can be stored in the soil. It can be received in precipitation, which sometimes we get out here and sometimes we don't. And in irrigation. When we start talking about precipitation, the next thing we have to ask is how effective is precipitation out here? Does all the rain we get actually get to the roots? I was at a meeting in Tribune, Kansas about, I don't know, 12 or 13 years ago now, and a guy presented some data that made me look, and I wanted to go see how the Oklahoma Panhandle looked. Beaver County, I just kind of went from east to west. We get right at 3,000 rainfall events from 1948 to 1999. 60% of them come at a quarter inch or less at a time. How much of that, if you're out here tilling, how much of that quarter, how many of those are going to be effective? How many of those are we going to either store in the soil, or is the roots are going to, if you've got a crop growing out there, are actually going to get used? So roughly 20%, so 80% of our rainfall events come less than a half inch. Think about that. 80% of the time it rains, we get less than a half inch of rain. And I'm sure it's pretty much the same way through the Texas Panhandle, all the high plains, because these numbers kind of showed the same thing they showed in Tribune. We start looking at Texas County, over 60% of our rain comes less than a quarter inch at a time. About 64, 65% of the time. We get a little less rain in Texas County than they do in Beaver County. In that 51 years, we got about 100 less rainfall events. The thing that I found fascinating in Texas County was in 51 years, we got 25 rainfall events over 2 inches. So that's basically a 2-inch rainfall every other year. It's not very effective rainfall out here. So whatever we can do to conserve it helps. And we go to Cimarron County, which is the far western county in the Oklahoma Panhandle. Again, it's about like Texas County. Although they do get a little more rainfall, or a few more rainfall events, let me put it that way. You guys in Dalhart, if any of you are from Dalhart, you get them summer showers coming off the mountains in Colorado. I used to be a custom cutter too, so I know all about rainfall events in Colorado too. So somewhere in Colorado it's going to rain every day in the summertime. So, but you get those mountain showers coming off. So whatever we can do to try to conserve a quarter inch of rainfall at a time is going to help us. So we've talked about that. Now, where are we starting out this year? I don't know how many of you are aware of, in Oklahoma we've got 144, I think it is, mesonet sites scattered out around the state. These report weather. They generate all kinds of pretty maps like this one. This one is actually water index at 10 inches below the soil surface. If it's 0, you're dry. If you're at 1, you're wet. Well, Oklahoma actually looks pretty good right, well, as of last week when I took this map down, at the 10-inch level. When you start looking at the 2-foot level, Texas County kind of sticks out. We're basically dry. We haven't received any rainfall. Part of the reason that Texas County sticks out, kind of the epicenter of the drought in Oklahoma this last year was this little red spot right down here in southwest Oklahoma. Tillman County and Beaver County at one time, or Cimarron County, excuse me. Cimarron County went 257 days without a rainfall of 1/4 of an inch last year. And they didn't set the state record for the driest year on record. That belongs to Hooker, Oklahoma. Since 1895, that's the driest year on record in the state of Oklahoma. The previous records was set in 1956 at 6.5 inches. And I'm not up here, I'm not a climatologist, I'm not a weatherman. I have slept in a Holiday Inn Express before, but you know, but I do report what the weatherman and the climatologist tell me. So that is the driest year on record. If we look from September 1 of 2010 through August 31st of 2011, it was less than 4 inches of rain in Hooker. And that's what the water people in the state of Oklahoma do now. I don't know if they do that in every state. They've got water years now. You know, the government's got their physical year. Well, the state's got water years, and they say that's October 1 through September 31st. So, but when you start looking at a calendar year, you know, since 1895, that was the driest year on record. And that shows why that red showed up in Texas County. We just haven't had any precipitation. So, my next question is, and I feel kind of left out, everybody's talked about corn this morning, and I'm going to talk about grain sorghum. How many of you raise grain sorghum? How many of you think grain sorghum's a crop? Now that's going to be my next question. I'm one of these that I've always I'm an OSU fan, long-time suffering OSU fan. So December 3rd was the greatest night I've probably had in my life. Never think I'll see it again. 44-10 beating OU. It'll never happen again. Well, that's the reason I kind of like working with grain sorghum. Everybody thinks of it as but think back 40 years for some of you guys that's my age and older. What was the predominant crop grown from here north? It was grain sorghum. It wasn't corn. I think we forgot that grain sorghum is a crop. But how do we value the water? It's the water use of crops. It's the yield increases we get by either precipitation or rainfall. The one I'm going to talk about today a little bit, and it's going to surprise some of you, is how do we value it? Dollars per inch of irrigation. How do you guys value it? Most of you plant corn because you can make more money, right? Are you making more money per inch of water, though? I got one guy sitting here shaking his head no. I see some guys looking at me like I'm nuts. Oh, they paid me for the comedy routine down here today, by the way. We got to look at the crop water requirements first. This is the major crops grown out here. Cotton, I've seen numbers all the way up to 27 inches. Takes about 16 to 20 inches. Sunflower, 14 to 18. Grain sorghum, I'll have some people argue with me. It takes more than that. I've got some data that says otherwise. It takes about 18 to 22. Wheat, 16 to 20. The other one people argue with on corn. Guys, if you're going to raise 200 bushel plus corn, the physiology of the plant is it takes a minimum of 28 inches of water to raise it. And it can take up to 36 inches, the higher you get. Got a producer in Oklahoma Panhandle, I'm not going to name names, pumped 38 inches of water on a circle of corn this year that made 225 bushel. Is that economical? I don't see anybody shaking their head like this out there now. But he cut 225 bushel corn. So, and then soybeans is not a whole lot different than what corn is, but it's a little bit less. With corn, all the literature out there suggests it takes 12 to 13 inches to raise the first bushel. Then you get about 10 inches for each additional inch of either rainfall or irrigation. With grain sorghum, it takes 6 to 7 inches. You get about 9 bushel increase. Sunflower, 7 to 8, and a 150 bushel increase, or 150 pound increase, excuse me. Soybeans, 10 to 12, 5 bushel. The one I found interesting is cotton because I couldn't get anybody to give me a good number. And most of you probably know Randy Bowman. He's now back in God's country. I mean, he's in Oklahoma again. They went back home, but he was you guys' cotton specialist here for a long time. He wouldn't give me a number. He said, I don't know what it is, to tell you, to be honest. So I talked to Dana Porter down at Lubbock. I just kind of come up with 12 to 13 inches. But they do know that you get about 70 pounds of lint and 100 pounds of seed for each additional inch of water. So when you start looking at the value of it, this is results at the research station at Goodwell last year. Best corn I had was 150 bushel corn. We're light water up there. We're somewhere between 450 and 500 gallons a minute. I called one day last week. Corn was $6.83 a bushel, and we put 21 inches of irrigation on it last year. This is not counting pre-water. This is just in-season rainfall. That made me $48.80 per inch of water. Well, I had a sorghum trial going on too. Best sorghum hybrid made 186. Price was $6.27 the same day I got the corn price, but I only put 10 inches of water on. I made $110 per acre inch of water with that hybrid. Hey, I've got their attention, Nick. I don't hear you talking out there. Anybody believe those numbers? Think they're right? I got a couple of them back here going. Is corn the most efficient? And don't get me wrong. If you got a 700-gallon well, raise corn. Well, some guy up here was talking about putting two 450-gallon wells to have 900 acre water raised. Why not just leave them 450 gallons and raise 2 circles of sorghum instead of trying to raise 2 circles of corn or 2 half circles of corn? What's going to make you more money in the long run? We forgot to raise sorghum because it's not a crop anymore. So some people ain't going to believe my numbers. So I went and averaged 32 hybrids that was in my performance trial. I made 155 bushels, same price, same amount of water. I still made $97 per inch of water. So that got me to thinking, and I'm scary when I get to thinking. But to show you how good my data is on sorghum, I wanted to show you this yield data from my performance trial. These are 8 hybrids that the last 2 years have averaged over 160 bushels per acre. Went from 160 to 166. Oh, shucks. I've got the results out in my car. Should have brought them in. But I had 2 of them make over 180, and then quite a bit of them make over 170. I had got a new plot combine last year. Went out and got to harvesting these plots, and my yields were coming back in, and I thought, man, they cannot be right. They just don't look like there's this much sorghum here. So I actually went out, got some sorghum, weighed a 25-pound sample and a 27-pound sample, and I run them through my weighing system on my blue plot combine, and they come out 25 pounds and 27 pounds. So the numbers are right. It surprised me. I didn't think it was there. But to go back to where it got me to thinking, and there's some people in Oklahoma will tell you that's dangerous when I get to doing that.